Hi, I'm Jennifer.
Hi, I'm Jennifer.
All right, so what first got you interested in computer science?
Oh, that's a good question. So I was working for a nonprofit organization that was promoting sustainable energy and building products. And I was working for them to basically as a database administrator to try to take all the data that they had about their donors and store that data and maintain it. And I realized that at the time they weren't doing a very good job of actually using that data to make predictions about who would likely donate more or how to expand their base. And so at that point I decided to go back to get a degree in computer science and figure out how to actually do this type of modeling. So that was really what motivated me.
Cool. So how did you decide that you wanted to focus on social networks for your area of research?
So I was majoring in computer science, and my passion was really in artificial intelligence, and at that point I got interested in machine learning. The faculty that I talked to, they said, well, you have to come up with a research project on your own, and that was a long time ago, but as I thought about it, what I wanted to do was something in machine learning, and I was very interested in the web at that point. Social networks did not exist back then, but I was interested in doing something about machine learning and the web, and so when I found a faculty member to work on that with me, he was working on relational learning, which is really how to take the components in these social network structures and put that into the models accurately, and so that was when I started working on modeling social networks.
So when you're working in the lab, how do you decide what problems you want to tackle? So you mentioned like looking at the citations for research papers and figuring out the topics, or figuring out the functions of proteins. How do you decide what sort of problems you want to tackle using social networks?
So there are various aspects of research in machine learning that range from things that are more theoretical, that focus more on just the math and the algorithms that we use, and at the other end of the spectrum are research projects that are more applied, where we try to actually just develop methods that will solve somebody's problem in the real world. And the approach that I take in my lab is really to go back and forth between the two ends of the spectrum. And so I like to find collaborators that actually have real data with real problems and talk to them about whether the existing methods that are out there right now for machine learning will work on their data sets or not. And if there's some reason that the methods don't work, then to me that creates a research opportunity to develop a new method for that particular kind of environment.
What's your favorite part about your work in AI?
I think there's a unique aspect to computer science and machine learning that is both a challenge and an opportunity, because we can help in problems in a lot of different areas. That to me makes it very exciting and very interesting to be in the field, but at the same time can make you feel like you don't have enough time to really address all the things that you're interested in. And so I guess the solution to that for me was to go on to become a professor so that I could have 15 grad students in my lab who would all work on very different problems, so that I can still have my fingers in a lot of different kinds of problems.
Right. So what do you recommend to kids who are interested in pursuing AI and machine learning but maybe don't know where to start?
So I recommend taking math classes. I think classes in probability or discrete math are, in addition to the normal classes that people take on calculus, I think those are the kinds of mathematical thinking that really helps in machine learning. One thing I see is that people might initially have a desire to study other fields because they've been more exposed to them, and they think that they'd be giving something up to switch to computer science. But in fact, you can really do very interesting work spanning multiple fields. So.
Cool. All right, that's all I have. Thank you.
Thank you.